Want to know how a process improvement culture transformed Cleveland Clinic into one of the world's top health systems? How real-time quality assurance benefits organ transplant programs? Then log on to the first all-virtual Health Systems Process Improvement Conference 2021, taking place February 24th through the 26th. Don't miss our keynote speakers, the Cleveland Clinic's Nathan Hurley and Hackensack University Director of Organ Transplantation Michael J. Goldstein. Register now to save big at iisc.org/HSPI/register.
This is Problem Solved, the IISE podcast, where we talk to industrial and systems engineers about their work, ideas, and solutions.
Hi, everyone. Welcome to another episode of Problem Solved, the IISE podcast. My name is Frank Reddy, and I'm the Marketing and Communications Coordinator for IISE. In this episode, we'll be talking to two ISE students from NC State about their experience as consultants for a new business venture called Easy Masks, which operates out of a hosiery mill in High Point, North Carolina. This discussion is an extension of a case study that appeared in the December 2020 issue of ISE Magazine. Joining me for this chat are NC State students Katie Lawson and Eric Swanson. Also joining us is Dr. BJ Lawson, a co-founder of Easy Masks. Welcome to the podcast, everyone.
Hey, thanks for having us on your podcast.
Yeah, thank you.
So how have things been going over at NC State, Eric and Katie?
Things have been good. It's just a lot of adjusting to things being online, coronavirus taking its toll on all the classes and not everyone's studies there at NC State. So very similar to what other colleges are seeing.
A lot of our labs have been pushed to an all online platform, which has made the experience with Easy Masks even more valuable because we, unlike our student peers, have been able to get our hands dirty a little bit solving these problems instead of just applying what we've learned in the classroom just on a computer. So it's been nice to get out and solve real problems instead of having an online lab or maybe have your curriculum cut out.
How different does it look like on campus over there, right in the middle of a pandemic?
It's pretty empty. I mean, usually you're walking to all of your classes. NC State's a beautiful campus, so we're walking through our brickyard and you see your friends and you're talking to all your classmates when you're on your way. And now everyone's in their apartments, everyone's following the CDC guidelines, and they're just doing class from their room. So it's a lot less interaction with the people that you know, and it's a lot more effort to try and keep those relationships alive.
I think students have struggled academically with not being able to host study groups and other formulations like that. As an engineering student, you really bank on group projects and that camaraderie around solving problems and helping each other understand what you're missing. And I think teachers or professors are seeing that as well as students because we're not able to get those study sessions like we used to.
Are you able to compensate with, Zoom sessions a little bit with that? And how different is that?
You are. It's always hard to, let's say, show your work to a friend over Zoom, though. It's kind of like, hey, can you read my paper through the camera? Wait, it's backwards, stuff like that. So it is a lot different to try to do these study calls over Zoom for factors that you wouldn't even realize when you're just like, oh, easy, do it on Zoom. There are a lot of there's something about being face to face with a person, being able to help them and get help yourself with what you're missing that really can't be done over Zoom.
Well, let's talk about Easy Masks. And whoever wants to take this question first, feel free. Can you give me a little bit of history of Covington Hosiery Mill and how they came to partner with Easy Masks?
Well, I guess I'll take that on behalf of Tyler and Braden and Chris Covington and the Covington team and the Harrison Covington team. So Harrison Covington is a 5th generation family-owned hosiery mill in High Point, North Carolina. They have been a longtime client of ours before, and actually even through and since COVID-19, I co-founded a company called EHOP Health, where we focus on helping employees reverse chronic disease. And Harrison Covington was one of our earliest clients. We've been working with HNC and their employees for about the past 5 years now and have developed quite a productive relationship with them and the management team. And Tyler and Braden and Chris are great. They're the brothers who run the business now. So when the pandemic kicked off in March, one of our other clients is a regional co-op grocery store, Weaver Street Market, and they were having trouble getting masks. So I was talking to their general manager. So I called Tyler Covington up and said, hey, Tyler, have you guys ever thought about leveraging your hosiery mills to make masks? And he said, well, we have just been kind of starting to explore that. And that really kicked off an intensive 3-4 week R&D skunkworks effort, going through several different iterations and kind of bringing in the R&D team at Harrison Covington along with the employees at Weaver Street Market, and obviously these talented ISE students at NC State to help figure out, okay, there's a need, how do we meet the need, and how do we get this product to market?
Gotcha. And did either one of you guys want to speak to that as well? Or did he just nail it?
I mean, he definitely nailed it. The idea to bring all three companies together to create a resource that everyone really needed in that time of panic. I mean, it's invaluable.
And one of the goals with Easy Mask was to keep the entire production line and resources North Carolina based to be able to help our state during this time of transition and during this time of shutdown. So all of our resources, and then, of course, the mill is located in High Point, North Carolina, but all of that is local. Our metal nose bridges come from the area in the mountains, I believe, in North Carolina. And it was important to us to keep it local and to not outsource things overseas, even if that meant a little more expensive labor costs or resource costs.
Eric and Katie, could each of you in turn talk about some of the ways your industrial engineering expertise was implemented at the mill and how effective that was?
Yeah. So when at first we started with just helping package masks when we had that sudden rush of orders because of the demand for PPE and the lack of masks at the first site of COVID. And we were just working in the mill when the mill was shut down. So we were fulfilling orders, and it started as a very small thing. You know, every company starts with maybe 5 people doing all the work. And once we got to the ability where they were deemed a necessary business, they could start bringing in some workers. And when they started bringing in those workers, Eric and I were saying there's a lot of inefficiencies in this system. And as industrial engineers at NC State, that's what we were trained to look for and trained to deal with, was different assembly line processes, how to limit time in your production and your assembly costs, or the production of the mask. That way you could get more per your unit time. And of course, always wanting to think about the ergonomics of the employee as well. So you don't want to overwork them. You don't want to make the process more difficult than it has to be for them. So we use, the one I'm thinking of right now is a time study, where we just took a timer and said, if we put these different parameters on how you produce the mask, how does that change the time and what does that affect? For example, when we first came in, they were using very narrow bags with a paper cutout that had to slide in with the mask. And the paper corners would get stuck when you were inserting them into the bag. And it doesn't seem like a big deal at first, but when you're packaging hundreds of these a day, it gets annoying and it slows you down to have those sharp corners cutting the bag. So solutions to that were either insert with rounded corners so they wouldn't catch on the bag, or a slightly larger bag to prevent that many corners from being stuck on the side. So it was little adjustments like that as industrial engineers were trained to see. And they were able to make that much more of an impact on their production cost and process.
Yeah, no, Katie hit the nail on the head. But the main thing that we learn about when we're at NC State and all of our ISE classes is efficiency, and efficiency is key. So when we came in there and we saw there's ways to improve the amount of masks that are being packaged per hour, and then that obviously in result will increase the production and also increase the revenue that you're bringing in. That's the goal. So that's what you're trying to do. So everything that Katie just explained was a great point of how we use what we learn in ISE classes and then apply it into the mill. And then also part of it was 3D modeling is another big part that we learn in all of our classes. So there's a non-woven insert that goes inside the masks. And one of the challenges that we had was when you put the non-woven insert into the mask, it's difficult to keep it from bundling up or scrunching up and keeping it flat so it does its job. So one of the things we look to do is create a 3D model insert that keeps the mask in the proper shape that it's supposed to hold when it's inside it. But keep the filter inside the proper shape that it's supposed to hold inside of the mask.
Anyone who wants to take this question can. And working with the mill, what was your impression of what it was like for them pivoting from making stockings and socks to making masks?
It was a difficult transition just because all they have done is socks. And one simple example of that is socks always come in pairs. And so do our masks. So when we're counting masks and different quantity, we'd always have to be careful with, if we're talking about single masks, then maybe we're talking about, it's not actually one mask, it's a pair of masks, because they always talk about pairs of socks. And the idea also behind the pair of masks is you can wash one and wear one. So while you're wearing one, you can be washing the other. So there is a technical reason behind the double mask, but also it made it easier to communicate with people who have been manufacturing socks their whole careers. I'm trying to think about other differences.
On all the tables that they used for packaging the masks, it's the same tables that you would use to package socks, and it's the same tools that you would use. So one of the challenges we found, especially doing our time study, was there's a metal sleeve that they use. They place 2 socks on top of this metal sleeve, slide them into the bag, and package them that way. And trying to do that with the masks and the paper insert that Katie was talking about earlier is more difficult than it is with the socks. And it's those tiny changes. It's not completely different, but the same tool doesn't work the exact same way with socks as it does with masks. Another
variation, not on the on the production side, so the manufacturing side, is our masks use a melt yarn to make the ear loops. And we've gone through a lot of iterations of this. And now compared to our first design, the ear loops are a lot thinner to give a much less bulky look. Hopefully it won't pull on the ears as much as a really thick band, but you don't really see tops of socks melting away. So to find the melting point and optimal time it should be in that machine for melting the ear loops away from the mask, so you would get a clean ear loop without any fraying. That was also a design challenge that everyone at the mill, and us included, tackled to figure out how to optimize that process.
And how many masks have been made there now to date?
It's at least probably close to 750,000.
Wow.
So it started out slowly, but demand really ramped up through the summer. And we were fortunate to get some wholesale orders from some grocery stores and retailers, and really were able to get a lot of masks out into the community when there weren't a whole lot of other options available.
So how does it feel for the three of you to see this go from just a simple idea and a partnership to this huge operation that's making that many masks?
It's really exciting to see a work that we've done firsthand and be a part of this growing company. People always talk about like how you're going to make a change and what you're going to do. And it is really exciting when you find something that is able to help people, especially in a time where everyone's taking COVID differently. It's all very new and it's an unprecedented time. And with that need of PPE and masks and something that actually works, and it's not just a face covering, right? It's actually something that will protect you and someone else. And to know that you're a part of that and that we have a product that is unique because of its 2-layer design with additional filtration, it's really exciting. And
yeah, and I would just like to say, and when you're in class, you have all these example problems on tests that you're doing that are describing the same situation that we're in here. But when you're actually in the situation, you're applying what you've learned, you really realize how much detail goes into all these different examples and questions that you're answering that you don't really see on paper. So it's been an invaluable learning experience just to see the true proper way of like what goes on in a mill and how to apply all of these things into our daily lives.
Yeah, it's really different than a classroom. I was giving someone else the example of when you do a physics problem and it's like, oh, neglect air resistance. When you're in the real world, there are all these other factors that they don't really teach you about in the classroom until you get there. And that has been just very impactful to both of our education. And I feel like we're both more ready for whatever career comes next because of these experiences with the mill and with Easy Masks and growing this company to such a large scale.
Katie, I wondered, I had a question for you here, and you just touched on it a little bit. If you would further explain the differences in working in a, quote, ideal setting classroom versus collecting and interpreting the data for yourselves in a real world environment, and what you've learned.
It's going back to what I was saying, how in the math and the sciences, there's always things you exclude in order to make the problem a little easier. Well, in real life, when you're dealing with real people and you're dealing with a real product and real demands, you're not going to have, let's say, a constant demand. So you could have a really high demand if we have a wholesale order, and the next week, maybe we're only online orders and you have less demand. So it's how do you deal with those fluctuating demands, and it's not just a steady increase or a steady line like we would learn in application questions in our classes. And it's things like that that teach you how to be a little bit flexible and think outside of the box with how do you deal with a fluctuating demand like that. On another level, I took an ergonomics class in school, and they teach you about all of these different factors that affect production. And it's stuff that maybe to limit carpal tunnel if you're working on the computer all day, or how to make the correct chair for someone to sit in. And when you're looking at a production line and you're looking at these people working, it's you just see how different people work given the same task. So when we were doing our time study, as textbook engineers, both Eric and I are like, why can't you all do it the same way, right? Like, why can't you put the mask in the bag and have it be a similar process that would optimize it? But you're not dealing with robots, you're dealing with people. And I feel like that's what the classroom fails to teach sometimes, because they're like, this is a uniform way to do this process. And when you're dealing with people, they have preferences. Even when I packaged masks versus Eric packaging, we had totally separate ways of doing it. Maybe I would add the mask first, and then I would add the paper, and he did it all at once. But what you want to do is you want to give them the tools to be able to optimize their style of production and to do the best that they can, because at the end of the day, you're working with people.
I wondered if you could kind of paint a picture for our listeners of what it feels like to be inside the mill and as industrial engineers, seeing that through your eyes. What was it like there?
It was a lot to take in at the beginning. Like, you walk in and they kind of have a front office set up where all of the main face-to-face action takes place. And then once you get back into the mills, when you see all of the machines they have for sewing and creating these masks, and the immense amount of stores for holding and housing socks, because that's what they're meant to do. And then all the space that they have and all the tables for the workers to sit there and actually package them and get them ready to send out. So it's a huge warehouse, and you only see like the very face of it if you're just like sending and delivering something to there. But once you're finally inside the mill, it's incredible to look at.
I don't think we have the numbers for like how many mills they actually have, because each machine that's what's called a mill for their weaving. But it is just aisles of mills that are all working and programmed by an NC State alum, actually, to make these socks. And it is, if you've never seen something on a mass production scale before, it is crazy to think about this is where your socks come from. Like, they're just spitting socks out within minutes, and then they move over to assembly stations where they're being packaged, and then they move from there and they move to the warehouse to get ready for delivery. And someone has to package all of these into boxes to then know where to ship them out via United States Postal Service or UPS.
Or more likely, big semi-tractor trailers filled with pallets of merchandise, which the scale at which the mill operates is really significant. And there aren't a lot of mills in the United States, very few, in fact, that have the capabilities that Harrison Covington does in terms of the number of machines, the quality of the machines, and really the caliber of the people doing the research and development, because the evolution of easy masks really pushed these hosiery mills, these machines, to their limits, and did things that the engineers who designed the hosiery mills never anticipated that they would do. But when forced to be creative and try to figure out what's the best combination of, fabric and fit to give you the best overall filtration performance, the mills were able to do it. And that was really a credit to the team of engineers at Harrison Covington who are running the R&D and figuring out how to poke and to prod and to push and really to push this technology to its limit in meeting the need.
And all of this paid off with the most recent JAMA article that was published. You want to touch on that?
Yeah, and it was interesting that one of the opportunities we had was to submit some samples for consideration at our other North Carolina University of North Carolina in Chapel Hill. And as it turned out, the samples that were sent as part of an RFP for Chapel Hill were then tested by a group that consisted of MDs and PhDs and both folks in clinical practice as well as people affiliated with the FDA or the EPA who were looking at the fit and performance of these masks. And a lot of times people will think about filtration that a mask offers simply in terms of what does the fabric do if you shoot particles at that fabric, what percentage of those particles are blocked by the fabric or by the mask. And while that's a useful starting place, it really doesn't reflect the real world, because in the real world, you've got to put this mask on someone's face. So it's not just the performance of the material that matters, it's also the fit of that material on the wearer's face, right? And a perfect example of the problem is when you look at people today who are wearing surgical masks or what we call procedural masks, which are really the paper masks with the ear loops or tie around the back of the head that are fundamentally designed to protect a sterile field from the surgeon working above the sterile field, right? You don't want, respiratory secretions or a cough or, a bit of saliva to come out of the wearer's mouth or nose and go into that sterile field. So it's a barrier. And when you put on a surgical mask, you're typically breathing around it because it doesn't seal tightly to the face. So what we were doing with the Easy Mask was fundamentally focused on making a mask that would be comfortable, easy to wear, and most importantly, you would breathe through it, not around it. So there's a metal nose bridge covering the nose and cheekbones. You've got what we call a face shield that is tight against the sides of the face and a good seal around the chin. So you put all that together and you've got a mask that seals rather well. And the UNC study that was just published in the Journal of the American Medical Association actually tested the masks being worn by an individual in a chamber with microscopic particles at a known concentration. And then that wearer during the test protocol moved his head around in a whole bunch of different ways following a protocol that's been evolved to say, okay, in real world, when someone is wearing this and breathing and they're moving around, how good a job does this do in actually filtering particles from the environment? And long story short, the Easy Masks outperformed surgical masks and other community face coverings that are available because of that attention paid to the fit as well as just the performance of the fabric.
No, when you're looking at the mask that you guys designed back in March versus the masks you're currently designing, what have been some of your lessons learned or improvements you've made?
Yeah, so one thing we mentioned earlier was when we started, we have really thick ear loops and they still had that melt away yarn. But looking at our mask today, we have a much thinner melt yarn that makes more of a thin, comfortable elastic versus having an actual seam around the ear that melted away. So that has increased comfort and customer satisfaction, having those thinner ear loops. They don't pull as hard. Also, starting out, we had one size fits most. And now one size mask does not fit most. Going back to what was previously said about the fit is really important to create the seal on the face. So we now offer a variety of sizes from a small to an extra large. And then we also, when kids were going back to school, we offered an adventure pack, which was for kids going back to school. So we had fun designs, fun colors, and they were made at a smaller scale to fit students' faces. And this is like elementary, middle school sizes.
Katie mentioned the majority of things. I was going to say stuff about the size. One thing that we also changed was the material that we were using. So we came through come the summertime. We wanted to have some cooler masks. We started to use, I can't even remember what the name of the material is called. Spandex? Was it spandex?
Yeah, we went from polyester to nylon, basically.
That's what it was, yeah.
We started with polyester, and then as we moved into the spring and the hotter summer months, nylon does a good job, both from the performance of the filtration, but it's also breathes a little bit better than the polyester does. So it was a bit cooler, although no mask is truly going to be cool on your face in a North Carolina summer. It was more tolerable than the polyester.
Now, is there anything else that anyone would like to add about what the partnership has been like?
I think both Eric and I would say half of both of us were very grateful for this internship opportunity or consulting opportunity to come in as industrial engineering students and look and see how we can help optimize their production, growing from just a few online orders to massive wholesale. And it's been a very exciting thing to be a part of and to watch our work directly affect the workers and the people that we're trying to get masks out to.
Yeah, and going off of that, just seeing 3 companies come together to solve a common problem and using the resources that they already had to solve this problem was a great learning experience of just how people come together to unite and fight against whatever the common enemy is, in this case being COVID. So just watching that happen in real life and seeing the steps in the process take place right in front of your eyes is incredible.
And Katie and Eric mentioned this already, but it was really neat that we were able to formulate a North Carolina-based supply chain for the ultimate solution. So everything from the yarns, which are coming from North Carolina, and they actually are recycled polyester, recycled nylon. So we're literally, with the polyester masks, taking former water bottles and turning that into recycled polyester yarn that's spun right in North Carolina. The metal nose bridges, as Katie mentioned, also sourced locally. So with the exception of the plastic bags, everything we were doing was from right there in our backyard, up to and including the polypropylene filter inserts, which when you put that non-woven insert inside between the 2 layers of the masks, we've had that independently tested, and a single insert inside the mask gives you a particle filtration efficiency of 80% at 0.3 microns. And if you put 2 of those inserts, which are very thin, they're about the thickness of a tissue paper, 2 of those together gives you 95% filtration at 0.3 microns, which, as you may know, is equivalent to what you would get from an N95 mask. Now, it's not tested as an N95 mask, but that filtration provided by the non-woven is actually, as the JAMA article demonstrates, giving the wearer meaningful protection. So it's not just about protecting others, it's also about protecting yourself. And when you're in a high-risk environment or in an environment where the air is likely to be stagnant.
Now, Katie and Eric, having gained this kind of experience during college, can you talk a little bit about what kind of plans you have for after college and what kind of goals you might have?
So I'm very thankful for the experience that I got to work and apply this knowledge that I learned. I'm actually a naval ROTC. So as soon as I graduate from college, I'll be commissioning into the Navy as an officer. And from there, doing whatever I need to do for the Navy. So, but it's great experience to have for my major, which is IISE. And should I ever leave the Navy and try to join and get another job with a company, this is a very great experience to demonstrate what we've learned.
And Katie, what about you?
Yes, so I am not in Navy ROTC, and I am in the process of looking for internships and jobs because I'll be graduating in December of 2022. So to have graduation kind of forefront, before it was kind of a long-term goal, right? It's 3-4 years ahead. Now it's 2 semesters. So it's all coming full front. So after graduation, I want to focus on some sort of sales engineering or project team, most likely in the medical device field. I've done research in neurosynchrony and seeing how you can optimize education through looking at actual brain reactions during an interaction. So if 2 people are talking, what their brains look like and how they can be synced up or on the same page, as that phrase goes. I've done other research in premature infants, but I really have a love for medical devices and being able to directly see the impact that you have on a person's life, just like we were able to see with easy masks. So the brain's always interested me. Medical devices has always interested me. So I'm hoping there's a connection there with neurocontrolled prosthetics or something like that I can be on the forefront of those emerging technologies.
Anything else anyone would like to add?
Thank you so much for having us on your podcast. And we also enjoyed reading the fantastic article that you guys wrote highlighting the Easy Mask and the Mills story with how we were able to apply our education in these weird remote learning times. It was exciting to read.
Yeah, it's been a real honor that you guys took the interest to come and talk to us. So thank you for that.
We appreciate you sharing the story with us. Thank you, Katie, Eric, and Dr. Lawson. It's been a great discussion. I'd like to thank you for taking the time to chat with us, and we wish you all continued success with the business.
Thank you.
You too.
Thanks for listening to this episode of Problem Solved, the IISE podcast, a production of the Institute of Industrial and Systems Engineers in Metro Atlanta. This podcast is produced by David Brandt, Keith Albertson, and Michael Hughes, and edited by David Brandt. You can listen to all episodes of Problem Solved and learn about sponsorship opportunities by visiting our website, podcast.iise.org. You can also learn more about IISE at the Institute's website, www.iise.org.